Hey folks, it's Mr. Viros, and we're gonna, in this video, look at problem solving. We're gonna start with some simple steps, and we're gonna talk about how we can apply these in physics, as well as a lot of other situations, to help us be better at problem solving. So, I have 4 steps written out, and as you go through solving problems in our class, as you tackle some of the AP problems for AP Physics, maybe on the test if you're taking the AP test in the spring. These are going to be really helpful. And you may have seen something like this before. These are very general, very broad problem solving steps. So you can tweak these, you can apply them differently to different problems. This is kind of a good starting point or a core for problem solving, and we can branch out from there to tackle different types of problems and different things that we encounter. So the first step that I always like to emphasize for problem solving is to define knowns and unknowns. And I apologize if there's noise in the background. I think there's construction on the building. So defining knowns and unknowns, we'll go through an example in a little bit and talk a bit about what that means. But defining knowns and unknowns is, what do I know about the problem? What information am I given? What do I already have and am I provided with? And unknowns would be, there's a lot of unknowns usually in a problem, but specifically what you want to know, but you don't know yet. So an unknown would be something that a problem is asking you for, like find the velocity of this object, or find the height from which this object is dropped, or something like that. So your unknowns is what you want to find, your knowns is what you already know. And listing those is really, really helpful for understanding, okay, where am I at right now? Where do I need to be for solving this problem? And then we're going to get into how we get there. So once you've defined your knowns, things you already have, and your unknowns, things you need, then you can move on to step 2. And the analogy that I really, really love with problem solving is solving a problem or fixing a problem using a toolbox. Because any time in physics that we're solving these problems, we're going to have a toolbox of things that we can use to do that. And these tools, so I listed here, select your tools, and these could be concepts. So part of your toolbox is deciding, what physics concept is this? Is this problem about motion in physics? Is this about forces? Maybe it's about momentum or energy. So there's some different concepts and things that we're going to explore throughout the year, and as we get through those concepts, you're going to have to pick which one of those applies best, or maybe there's multiple that apply to the situation. So deciding, all right, which physics concepts are going to be applied here? And then equations, this is sort of your math side of it, right? So when we apply physics concepts to solve problems, the vast majority of the time we're using some sort of equation. So that might be, like in math, right? We'll go through an example, a simple algebra 2 example that talks about equations and how we use them. But in physics, we have lots of equations, and you're going to have to be able to select which particular equation is going to be best and most helpful for finding that unknown, that thing that you want to know, based off of the knowns and the things you already know. So we'll get into that more specifically with specific problems. But so your concepts, your equations, and then skills, this would be general critical thinking skills and problem solving skills. Things like just trying not to make it more complicated than you have to. I'll kind of touch on that in an example in a little bit. So these skills, this mostly is based around your ability to use critical thinking to solve the problem in an efficient way, in a way that makes sense. And it may not be that there's only one right way. So you can use skills to say, I'm going to solve it this way, I'm going to solve it a different way. I've seen lots of incredible examples of students who solve problems that I didn't even think of a certain way to do it, but they came up with that, which is awesome. So your concepts, your equations, and your skills, you're going to need to select, all right, which of these do I need for this specific problem? And I'm going to kind of pull those out of my toolbox. Those are going to be the ones that I'm going to use for this problem. Steps 3 and 4, these are the really big important ones. Once you do these, you know what you're given, you know what you need to find out, and you know what tools you need to get there. That's really the big part. Of course, you have to do steps 3 and 4. So 3 is just, once you have all these tools that you have, now you just need to apply them correctly to solve the problem. Showing work is really important here. I know not everyone in our physics classes is going to go into engineering or something like that, but if you do pursue a career like that, showing your work and those steps of how you got there is very important. I did some engineering classes in college, and it's this long process of step, show your work, show your work, show your work. So for our physics classes, it is very important while you're applying these concepts and equations to get to whatever it is you're trying to find out. You need to show your work while you're applying those tools. So it's pretty, as we go on in physics, this will have lots of different ways that it looks like. But for now, we're just going to say applying tools to solve, and usually that involves some math steps as you go through, sometimes a lot of math, sometimes less math, depends on the problem. But also, step 3 can involve a lot more conceptual things too. You may not even be using math or an equation or numbers. You might just be saying, okay, I know that this concept or this law in physics states this, so therefore, based on these concepts and my understanding of them, this must be the answer to the problem. So it could be a lot more conceptual as well. Step 4, check your work. That's just a really important thing. I think I would have gotten a lot better if I had bothered to go back and check my work in college or in high school while taking physics. It would have gotten rid of a lot of the mistakes that I made and cost me, points on a test or points on homework or something like that. So checking your work, very important anytime you're doing something involving math and equations. There's always those little mistakes and things that get switched around and backwards. So going through and just making sure, hey, I got it. I checked everything. I double checked it. If you have the time to do that, on an assessment or a test, highly recommend it, because checking your own work and making sure there's no little math mistakes, because they also feel bad, right? You come back to that and you're like, I made a tiny number mistake. That's the worst. All right, so those are our steps. I'm going to go through just a brief example. We're not into physics concepts yet, of course, but I'll go through and use kind of an algebra example. So let's just put an equation up here. So 2x squared plus 7x minus 12 equals 0. So if you've taken Algebra 2, you've seen some sort of equation like this. So we have a 2x squared plus 7x minus 12 equals 0. And of course, your problem would probably say, find the value of x. So in this case, it's a very short example of this. Some of our physics problems, we're going to have word problems where you have to kind of pull out from a word, sentence or paragraph, what are the knowns, what are the unknowns, kind of tease out what those things are. In this case, it's pretty straightforward. We know that we have this equation, right? So one of our knowns would be, this is our given equation. Another known, if you're classifying things, okay, this looks like a quadratic equation. That's one of our knowns. And then our unknown, we have to find x. That's what we're asked to do. And if you probably calling back to your Algebra 2 days, when we want to select tools, part of it is, yes, we need an equation or equations. Could be multiple. We need skills, we need concepts, but there might be multiple ways to solve this problem. You could probably do all kinds of things, and I'm not a super heavy math person to the point that I would be able to do tons of different ways to solve this problem, but you probably could. And one of the things we want to do in physics, and in any problem solving probably, is to pick a nice efficient way to do it. So it's not just any equation or equations. We want to find the best, most efficient way. So from your Algebra 2 skills and concepts and equations, what we would want to pull out from this is, okay, we have this thing called the quadratic equation. And we can use that to solve a quadratic, this equation here. So our quadratic equation, x equals negative b plus or minus, or no, plus or minus square root b squared minus 4ac. Let's see if I actually get this right. All over 2a. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, I think I got it right. I haven't been able to forget this since high school. It's been stuck in my head. I even learned a song, but I'm not going to sing the song right now. So this is our quadratic equation. It says, in order to solve for x in this equation, we can just say that we have to understand what this means, right? All these a's and b's and c's, they won't make any sense if we don't know, oh wait, we know that this 2, the coefficient on x squared, oh, that's our a. So that's a concept, or even what you might say a skill that you learn in Algebra 2, that this equation applies to this problem where the coefficient is a, here's our b, is that 7, 12 is c. Okay, so now that we know that, and we've selected this tool correctly, this equation, and we know that the b and the a and the c are these numbers, these coefficients, now we can apply it and go through, and I won't even bother to do the math, but of course we could plug in, -7 here, 7 squared, so on and so forth. And we would get a numeric answer for x, where there'd be obviously 2 answers. That's the way that our quadratic equation works. You'll get one answer from -b plus all this, one answer from -b minus all this, and those 2 numeric answers would be what we're looking for finding x. And again, I'm not going to do it now, but as you apply the tools to solve, showing those steps, right? So you take this and you might move it down and say, I'm going to put in all my numbers first. Instead of -b, I'll put in -7, so on and so forth. And those steps, showing the work and taking the steps in part 3, is what's going to help you avoid some of those problems that you would catch when you check your work. So the more methodical, the more systematic you can be about solving your problems and clearly showing your work in an orderly fashion, the less mistakes you'll make, most likely. And it's also easier, if I'm grading something, that'll help a lot. So this is just an example of this problem solving, but I think these 4 steps are, from my experience so far in physics for myself, they're just a helpful way to think about problem solving, to start with your knowns and unknowns, select your tools, your equations, your concepts, your skills, and then apply those while showing your work in an orderly, organized fashion, and then of course checking your work to make sure that you don't have any mistakes along the way. And as I mentioned at the beginning, this can be tweaked. There can be different stuff that you would do with this. Maybe you'll make your own version of this, which is great. So find something that maybe building off of this that works for you when you're solving problems. But I do like this sort of set of steps as a starting point for problem solving. I'm looking forward to doing lots of problem solving. Physics is full of it. Again, not all of it is all numbers. There's a lot of equations, a lot of numbers, a lot of math. But sometimes it's more conceptual and just thinking about the concepts as well. Or even some lab activities, right? So lab-based things where you figure out, how do I set this up in order to find something that I want to find out, or do an experiment to get some data that I want to gather. So there's all kinds of stuff, but at the core of most physics problems and things you'll see on the AP test and in our class is this idea of problem solving. And so we need to be familiar with that and get some good practice in on it. All right, thanks y'all. We'll see you around.